Okay, let's start off with yesterday's homework. So the first question was to print the pattern, the upper triangle, right? So this is the program for that without using any for loops or anything. I saw a lot of people had submitted answers who used for loops and all that. That's pretty good. But this is the one without the for loop. So I'll just show you the output. /t, which will give you tab space, and /n to give you new space. So pretty straightforward, nothing much to look into there. And after that, the next output will be the, what is that? Yeah. And this is the output for the pyramid. So you give 3 tab space and then you reduce the tab space and just go to the next line every time. So that was yesterday's homework. Now, let me tell you about comments quickly. Comments are used in C++ to tell the user about something. For example, if you need to tell the user this is a upper triangle. This is an upper triangle, and you just need it as a text in your code, just like that as a text. And if you want to do that, you can just do this like /. If you type /, it comes in as a comment, which means that the compiler will not detect this line. Okay, it will not read through this line. It will not check for errors. This is just used for the user to just put it up as a message, like this is a upper triangle, and I'll just put in this is a pyramid. Okay. And when you need to use multiple line comments, like for example, this works only for this line, this specific line, 15th line. If I type something in the 16th line, as you can see, it won't be a comment. So to make that a comment, you need to do this / and a star. So if you do / and a star, it means that it starts commenting from that line and keeps commenting until it encounters a star and a slash. Okay. So if I remove this and this, none of it is commenting. All right, now I'll pass over the screen sharing to Benison, and he will teach you the next coming up sessions. Just a second. 1 second. Benison, are you here? Benison?
Yes.
Yeah. Over to you.
Okay. So I see we have only 14 participants who have still managed to join. Okay. Are you able to see my screen right now?
Not yet. You check if the screen is shared.
Yeah. Just a minute. So, welcome everybody. Today we are progressing to day 2 of competitive programming in C++. So let's start right off. These are the topics we'll be covering today, which will be data types, if-else statements, and header files. Just give me a minute. Yeah, so I'm not able to see the chat. Agni, can you guide me where that is?
Control+H, Alt+H, that will give you the chat, I think.
Okay. Yep, I've got that, thank you. Okay, okay, so proceeding further. These are the data types. These are the data types we have in C++. Int, float, double, char, and string. So these are all keywords. Keywords are words which are recognized by the compiler. So C and C++ are compiled languages. You don't need to go in detail to what is a compiled language, but just for information, it's a compiled language. So it has a thing called a compiler, which it converts what we write in human language to what is understandable to computer in the computer format. So these first 3 categories, that is int, float, and double, they deal with numbers. Now they're used to represent numbers in any the various formats they appear. And the following 2, char and string, those are used to represent strings, as in like a collection of letters and that sort of. So let's move on to the first one. So we have int. Int is a short form for integer. I hope all of you are able to follow. If you have any queries, please do feel free to raise it in the chat section. I'll be viewing the chat section regularly. So today we have the integers. Int is a keyword for integer. So int is basically, it takes up 4 bytes in computer memory to represent it. The range, as you can see on the screen, it's a pretty huge range. So, but then it's only up to 10 digits. So you see, like it has like 10 places. So if you give it a 11th place, that's like if you give it a 11-digit number. Basically, these these words that these keywords that I showed over here, it's used to tell the compiler what type of what type of value is being stored in a container. So you have variables. So all right. So basically, variables are what you do all your operations with. There are variables, and then there are methods, and there are a lot of things like that. So variables are basically things, containers in which you put your data in. So these keywords here, they tell the compiler, they tell the computer what the kind of data can be put into that variable. All right. So this is the value which can be, for integer. This is the values that can be put inside an integer variable. I believe you can see on the screen this example. Int a is equal to 1000. So it assigns the value 1000 to a. In fact, any value within this given range shown on the screen can be assigned to that variable a. But then if you assign a value which is more than, like, which exceeds either of these boundaries, you'll get something known as a garbage value. That is, you will not be getting what you gave as the input. You'll be getting some random number. All right. So how to deal with all that, and Agnen will be showing you in the practical session. We'll be alternating between theory and practical sessions. So first I'll be covering the theory, and Agnen will be showing you the practical hands-on. So the next division is float. I hope I'm not going too fast. Is everybody still able to catch up? Yes. Okay. Thank you. So next we have float. So float is a floating point. So now in numbers we have numbers which have decimal values, right? So there's the decimal point. So those type of numbers cannot be represented in using the integer data type. So for that we have float data type. So as shown on the screen, that is the data range which can be accommodated within a floating variable. So float actually, there's a mistake on what's shown on the screen. Float a is equal to 1000, but then actually if you can't when you assign it, you have to put a 0.0. It's like 1000.0. It's you'll get clarified on that when you see the practicals. Okay. So it assigns, there is a point, at least point, and then there is one, what do you call it? After the point, one decimal one place over there. So 1 10 raised to minus 1 power. Right? Yeah. So yes. Anybody? Somebody's mic is on. Yeah. Okay. This should be 1000.0. Yeah. Then we're good to go. So next we have integer floating. Float, yeah. So float is basically used to denote numbers with a decimal point, and there is a certain precision. I hope all of you know what precision means. So what precision means is, to what extent the number represented is accurate to its original value. So there is always a certain amount of loss when you're representing data. So like if you say, like if there are like 100 zeros and then there's a 6 at the end of those 100 zeros, you probably might, it doesn't make much of a big difference when you check on when you look at it from a human perspective, but then in certain calculations it might make a big difference. So we have the next data type, which is double. So in double, you see it has more precision than float. Okay, so it has like almost double the precision, I believe. So you see in the previous one we had only 10 raised to minus 45. In this one we have 10 raised to 300 minus 45. That's like really huge difference there. So it has like a large difference in when it comes to precision. And in competitive programming, it does make a lot of difference, because the number of mm, yeah, so double is more like float. It's like a bigger version of float rather than rather than integer. So now I guess that's all. Okay, yeah, we have two more to cover. uh, Next we are going for string characters. Yeah, okay. So first we have characters. Character is basically each individual alphabet, or you can also store numbers as characters. So you like example given on the screen. You have character A is equal to X. So the character X. So that's how you represent characters. You represent characters within single quotes. You can also do that in double quotes, I believe. So that's how we represent a character. You can also put us in 1, 0, 1 to 9, 0 to 9, all the numbers through that, and the alphabets within single quotes, or anything on the keyboard. You can put within single quotes and assign it, but there can be only one. Okay, so that's for usually characters is usually used for single letters. Now, what if you want to represent, a combination of string, like combination of characters, like multiple letters or multiple numbers? Multiple numbers, of course, we have integers, but the int and float and double and all that. But in certain cases, you might want to represent numbers also in the form of strings. So in that case, or like if you want to, like represent your, say you want to represent your, what was that called? Your registration ID in the university. So it's a combination of letters and numbers. So things like that, you can represent that using this strings. Okay, so strings are usually for a collection of single letters or like multiple letters or letters and numbers, alphanumeric, whatever you want. So you put that in quotes, and there you get a string. So string is also a data type in C++. This is how you assign it. Now, I guess we'll move on to the practical session and see there. Yep. Agnem, over to you.
Yeah, okay. 1 second. Let me share my screen. Benison, can you turn off your screen sharing?
Yep, my screen sharing is
Thank
off.
you.
Thank you.
Okay. Now let's get to the practical session, as Benison said. Now he told you a lot of data types, right? Integer, float, double, character, and string. Now these are the basic data types within C. Now there are more data types which are created by users, explicit, a lot of other data types. Now let's just get to these. Now this is how we initialize them. Int A, B, C. Now A, B, and C are three containers which can store integer type variables. Okay. Now you can initialize them like this. A is equal to 10, B is equal to 20, and C is equal to whatever you want, 0 or anything. Or you can also take them as input. For example, C in C. Now this whatever you enter gets into C. Okay. And same way you can print them out. C out C or C out A, B, C. I don't need to show you that. It's very easy to do that. Now, next, coming to, as Benison told you about the range. He told you something about the range, right? So let's see. How many of you remember the range of integer? How many digits can it store? Come on, somebody in the chat. Guys, do you remember the, okay, 10 digits. Arjun says it's 10 digits. Now, anyone else? What's the maximum number of digits? Okay, 10 digits, fine. 10 digits is the maximum size. Now, what happens if we get 11 digits, for example? Let's just run this thing, okay? C in C and C out C. Now, what I'm going to do is, sorry. Oh. Now, if I now it's supposed to take in C, right? C in C. Now, what if I give a number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, this is like, I don't know, 9 digits, 10, 11, 12, 13, 14, 15 digit number. And if I click enter, as you can see, this is just printing me some random garbage value. This is not even any part of the number that I entered. It's giving me 2147483. No, this is something else. So what happens is whenever an integer variable takes in a number that's bigger than its range, it just replaces that number with some garbage value. Now, this can be very problematic when it comes to competitive programming, because in competitive programming, we'll be dealing with huge numbers. Like, there are questions where you need to deal with 100-digit numbers and all that. So, you need to be very careful with that. So, you need to initialize data types appropriately. Now, that's one thing. Now, what if I do this? See out, see on, and on the other hand, what if I, what if I, instead of typing 10, what if I give 0.5? As you see, there's no error for this. It doesn't give an error if you enter a floating point number. All that it does is it just, ignores everything after the point. Now, I'll show you another example. If I type 100.55443, it just gives you 100. It just ignores everything beyond the point. Okay. Now, that's one thing. After that, coming to floating variables, as Benison told you, it's the same as integers, just that it has a bigger range and it can also accommodate points or decimal values. Double is the exact same as float, but just that it has a bigger range than float. Okay, now we'll be moving to characters and strings. Now, here's the tricky part. Okay, characters, as Benison told, you can store numbers inside characters. You can store everything inside characters. Okay, so C in X and C out X. Let's just see if it comes. The character you entered was and X. Okay. Now, if I give in 8, the character you entered was 8. Okay. And if I give in, minus, or let's give semicolon. The character you entered was semicolon. As you can see, there's no problem. Anything on the keyboard, anything that has a valid ASCII index can be stored inside a character type variable. Okay. Now, as you can see, what I did here was, see, as I showed you, you can store number 4, right? Now, if I give in 4, it stores the number 4. So let's try and do some operation on it. See out X plus, let's say int A, or we already have initialized A. See out X plus A. Okay. What is it like? X is, and let's give X as 4, because first thing is it's taking input as X. So if I give X as 4, and if I do X plus A, it's giving me 462. What is this? 462. That's a very weird answer. So you should not do this, because what happens here is it converts it into ASCII characters. See, it outputs X as a character because X is a character type, and then outputs plus A, just converts it into character, and it just converts it into ASCII values and gives an output. So you should be careful with that. If I give X plus 5, let's see.
Hi, Agne.
Yeah.
Excuse me. Yeah, can you explain what ASCII characters are to everyone?
ASCII characters, I thought of explaining it in another session when we entered competitive programming, because there are problems specifically related to that. So,
okay,
what do you say about that? It's fine?
Yeah, okay. It would be fine if you could just brief what it is rather than going into more details.
ASCII characters. ASCII is, if you enter anything to a computer, anything from a keyboard, the computer interprets it as an ASCII character, ASCII value. Let me just give you an example. What is ASCII characters? ASCII table is ASCII table. Now, what this is, it's as you can see here, this is a list of numbers. 0, the decimal 0, null. Okay, the thing null has ASCII value 0. Okay, sorry, and another thing, the character A. Okay, this character A has a ASCII value 65. So what happens is when you enter A in your keyboard, it converts A into the its ASCII value, that is 65, and the computer stores it as 65. Okay, so that's how the computer interprets it. Now, this is very useful when it comes to dealing with characters. Okay. And plus has the character, see everything on the keyboard. You can see everything on the keyboard here has its own corresponding ASCII value. The number 0 has an ASCII value 48. Okay, this you have to be careful of this. Number 0 has an ASCII value of 48. The number 1 has an ASCII value of 49, and not the number itself. Okay, so ASCII values you can get this easily. You don't need to memorize this, but you will be needing this sometime. You can just Google an ASCII table and you'll get this. You can use it whenever you want. Now, let's get to the next part of it. Now that's characters. Okay. Now after characters, Benison told you something about a string. Now how do you take in strings? C and S. That's all. You can take in strings like that, and I can take in Agneyan as my name as a string. I didn't output anything. Okay. C out S. It's as simple as that. You can just manipulate it like a variable. Agneyan, and it outputs Agneyan as I had entered it. Now the main highlight about string is you can access its characters individually. Okay. This is how you do it. S is the name of the string, right? So you input S and you output S of 0. Okay. Now what happens here is I'm taking S is considered to be, as every character in a string is considered individually. Okay. And that's exactly how you can manipulate them. Now if I give S of 0, let's see what happens. And if I type in Agneyan, it prints out A. Okay. It's just printing out the first character in S. So first characters are represented by zeros. The next character will be 1. This will be 2. This will be 3, 4, 5, 6, and 7. Okay. So the string totally contains 8 characters, but then the indexing will be from 0, 1, and so on till 7. Okay. So you should be careful about that when manipulating strings and everything. Like everything. Next will be coming to arrays and other data structures. They all use indexing starting from 0. Okay. That's one thing. Now if I print S of 5, it's just going to, 7. AAGNEYN. So the fifth character 1, 0, 1, 2, 3, 4, 5. It's supposed to print out Y. Yeah, see, it prints out Y. So this is how you can manipulate individual characters of a string, which makes it very much more powerful than other things that we've learned. Like integer over here, you can just take in 1. If you take in 100 as an integer, you can't print out 1 or 0 on its own. Just like that, you can't do A of 10 or something. You can only do it with strings. Okay. So that's one thing. And string can also store multiple data types. For example, if I type in A153 opening brackets, closing brackets, like all these together, it'll just take in everything together as it is on the output screen and take it in. Just as how you input it in the keyboard. So that's one another highlight of strings. They're very powerful. You can input anything you want into strings, but you have to be careful at the same time. If you input a number into a string, you can't use it like a number. You'll have to use it like a character, okay, or individual string element. Now after that, we'll be going to the next topic. One second, something is in the chat. Just a second. Okay, so this is how you access string elements. You can access individual string elements or, as I told you, entire string. And this is called the index, okay? S of 0, S of 9, S of 10, S of anything, whatever you want. Strings have infinite storage, Strings have basically the storage of a computer. So, wait, that's another thing that makes it so much powerful. As I told you, integer and double, they can store a maximum of 308 digits or something. Benison told you that the double has a total precision of 308 digits. But when it comes to string, it can literally store whatever the size it wants. Like the entire memory of the computer. That's what the size of the string is. So there is no limit to what the string can store, okay? Which is another thing that we'll be using in competitive programming, okay? Nirmal's asking me, does the index always start from 0? Yes, the index always starts from 0 if you don't specify anything. See, I'll tell you how to change the index later on when we enter for loops and while loops and other things. As of now, for everything, for arrays, for strings, everything, index starts from 0, okay? Now, before moving on to the next topic, does anybody have any doubts? Anyway, you guys have doubts, please ask right now, okay? Because this is a very important topic and we need to be strong with it before we move to the next topic. Naveen says no, Aditya, okay, you guys are doing good. Everybody's fine, okay. Now, the next topic for today is header files. Just a second, let me get to header files, yeah. Now, as you might have observed in this previous code which I showed you here, I told you yesterday about IO stream, right? Input output stream. It helps you manipulate between input and output. As you can see here, this is another new header file that we're using right now. It's called string. Now, why are we using string? We're using string because we are manipulating strings over here. We are initializing strings, we are using strings, and to use strings, you need to have this header file string. Okay. So what a header file does is, now let me get to what a header file is. Okay. Okay. Header files contain the definitions of functions and variables which are important to C++ using a preprocessor hash include. Okay. What that means is you are importing a header file into your C++ program using a hash include statement, and you import string. Now what happens is the C++ imports a string library into the program, which enables all the functions and all the variables which are inside string to be used. Okay. Now another example of a header file is hash include math. Math.h. Now, hash include math.h is another header file. Now what are the math.h basically contains functions that you use for mathematical functions like square root, power. Let me just give you a quick demonstration. Okay. Now cout POW A, 2, A, B. Now what happens here is POW is the function which is inside math.h. Okay. So since I've called math.h a header file, we can use the function POW to our, however we want. Now if I cout POW of A, B, it does A raised to B function, A raised to B. So what is A raised to B is 10 raised to 2. It's supposed to come as 100. Let's see. 1 second. We don't need this anymore. Cout POW A, B is 100. 10 raised to 2. 10 raised to 2 is 100, right? There's nothing wrong in that. So that is another new header file. Now another function of this header file could be sqrt, square root. Sqrt of 4, square root of 4. What is that? Square root of 4 is 2. See, all these functions can be implemented using math.h. Now, on the other hand, if I remove math.h, let's see what happens. We are using a function which is supposed to be in math.h, right? Sqrt function is used here, but there's no math.h. Let's see what happens. See, it's throwing me an error. Error sqrt was not declared in the scope. Now, this is because we didn't give hash include math.h, because this function, sqrt function, is included inside math.h. So if we don't call math.h, the compiler will not know what sqrt is. What is sqrt? Obviously, it won't know. So it'll throw you an error. So be careful about what functions you're using and use data types appropriately. Now, that's one important topic. So there are many header files. So let me give you a reference over here. This is a website. You can copy it down anywhere. I'll be sharing the presentation with you, and this video will be there anyways. So what this does is you can go to a new tab and spaces. Once I can show it to you. Yeah. This website, this contains all the list of standard header files that people use for C++, SC, stdlib, c, you won't be using a lot of these, but it just contains everything. So if you have any doubts, you can just refer to this using this website. So it's showing there are a lot of functions inside this. So if you want any reference, please use this website. Okay. Now we'll be heading on to the next topic, which is if statements, and I'll be handing over the meeting controls to Benison. Just a second. Benison, are you there?
Yes.
So I'm giving the controls to you.
Okay. Thank you. Just a minute.
If-else statement is basically very important when it comes to any programming language. So be careful. Listen to it carefully. Okay.
Okay, so
before that, one second. Before that, do anybody have doubts in the previous section about header files? Do you guys have doubts? Hello? No from Naveen? No. Okay, fine. All right, let's go to the next section.
Yeah, okay, fine. So next topic we have if statements. So basically, how we take decisions in our day-to-day life. We have information. So we process the information. Like if we are all assigned marks we are all assigned grades based on our marks. We are told if we pass or fail based on our marks. So if statements are very useful in making decisions, just having data is not enough. You need to be able to make decisions with them. That's only when you are able to exploit the power of computer. So when you have data, you have the power to make decisions based on them. So basically, what you do is if if it is like if you have more than 45 marks in an exam, you pass, or else you're declared as you have failed the exam. So that's basically what you do with if statements. So now regarding if statements, what you most importantly need to learn is the syntax, the how you write it, how you write the statement in C++. So I believe this example is visible to all of you. Yeah, so we have, as you can see, you have the header files, you have using namespace std, started the int main. You have declared, this is called declaration. So char a, you have declared a container a variable a, and you have told the computer that it is of type character, that whatever it is containing will be of type character. And the next line, you get the input. So if statement. Now coming to if statement, this is the this is how you write an if statement. You write if, okay, you write if, and then you open parenthesis. The space is not necessary. If you want, you can have a space. If you don't want it, don't feel like having it, it's not necessary. It's up to your choice. So you open this parenthesis, and within the, you see, within this opening parenthesis and closing parenthesis, you write the condition which the computer has to check. That is, if that condition is true, the following section has to be executed. So we always have a condition like that. So that condition which is to be checked is given within this parenthesis. Here our condition is if the container, if the variable has this whatever is present inside the variable, the checking if that is equal to the capital X in the alphabet. So if it is so, then we will output. So after you have written if, and after you have written the condition within the parenthesis, you open the flowery brackets, and within the flowery brackets, you write the code, whatever has to be executed. If that condition, if that statement, that is the if condition that you have given, evaluates to truth. Let me repeat that once again. So if the condition that you have given is true, and whatever you want to be executed when that condition is true is to be written within this flowery parenthesis. All right. So it's basically a recommended practice that you write it within this flowery parenthesis. Because right now here we have only one line which is to be executed. So if we don't have these parentheses, it will work just fine. Because in the event that these parentheses are not present, what the computer does is, if the condition given is true, if it evaluates to true, without the parentheses, it would just execute the first line following the if. So it will not, if you have more than one statement, then it would be a problem. So it's always suggested to have parentheses. Okay. So what if this if condition does not evaluate to true? Like it's not always necessary that this if condition will evaluate to true. So if it happens otherwise, like if it evaluates to false, then you have an option to define an else condition. That is, if the if condition fails, then you have an else condition. So the else condition also is written like this. Like else is the keyword. So you write else, and then you open this flowery brackets. You don't have to mention any conditions here. All right. There is also else if. We'll come to that later. So there is else, and then you open the flowery parenthesis and you close the flowery parenthesis. Within that, you write whatever code is to be executed in the event that your given condition evaluates to false. All right. So that's almost it. And then, yeah, okay. So we have else if. Like I said, we have else if. So what happens in else if is, else if will be shown by Agnen when he is taking the practicals. So we also have nested if. That is, within this flowery brackets. That is like you have given the if condition over here, and you have opened and closed these flowery brackets, and within that you have given this cout statement. So if you want, you can add another if statement within these flowery brackets, and that will be called an nested if. That is like, you know, an if within an if. So you can have how many other layers you want like that. Like you can have 20, 30, 40, 100, it doesn't matter. You can have as many if conditions as you want within an if condition. So it's basically like, you know, if you have multiple checks, like, you know, if you have, suppose you want to say, like, suppose we want to assign you a grade. So first you have to check if that person has passed, right? So because if that person has not passed, then there is no need for further checking. So first you check if that person has marks above 45. Okay. So that is the first if condition. If marks greater than 45. So if that condition is true, okay, fine. Like if that marks is greater than 45, then you check if that person's, in which category that person's marks falls into. And like if it is greater than say 60, you assign a grade, or if it's greater than 80, you assign a grade, or something like that. So that's basically what you use nested ifs for. So how much time do we have remaining? Okay, we have enough time. Okay. So I guess that'll be all. Again, if you're ready to move on with the practical session. Okay.
Yes, screen.
Yeah, just. Yeah, sure.
Okay, now getting to if-else conditions. I hope you understood what Benison told you, like, you know, the theoretical part where you need to, how to assign if conditions, how to assign those. Now let's start with a simple example, okay? Oh no, you don't need to be very simple. Let's go in A, C, in A, if A greater than 0, what is it? Print C out positive, else C out negative. Okay. Now if I take the output screen C in A, let's enter number 5. So it shows positive. And if I enter number -5, it shows negative. Okay. Now let's see see out positive. Now along with this, if A is greater than 0, I want to see out positive. I want to tell that the number is positive, and I also want to output that the number is what the number is, see out A. Okay. Now see out positive and see out A. Similarly, if it's negative, see out positive and see out A. Let's try running this program. Oh, what is this? Else. Okay. Can somebody tell me what the error was? Let me show it you again. Else without a previous if. What does that mean? Does anybody have an idea what it is? Does anybody know why this error came? Brackets. Yeah, that's a correct one. The reason is brackets. You need to be very careful with this because, yeah, multiple lines. That's also another reason. Now, what happens with an if condition is if there's an if condition and if there is one, you know, what it should do if the if condition is true. That's what the next line will be. Okay. So if it is just one line, if there is no brackets, then what it does is the compiler just executes the first line as a part of the if condition. Okay. This is not like Python. In Python, you don't need to, you can write multiple lines with just an indentation. Okay. So be careful about that. It'll just, do everything. But in C++, you need to be careful. It'll just do the first line. So put in brackets. The first opening brackets, closing brackets. Now, if I save this, it goes fine. But be careful that the same thing applies for else. Okay. Now, if it is a negative number, it's going to see out the negative number and then see out A, regardless of the negative number, if it is positive or negative. Okay. Let me show you the example here. Now, if I output 5, let's see, if I take A as 5, it shows positive and 5 because this cout A is not under the else statement due to brackets. Okay, you all understood what brackets are now? Brackets are important for, and if else conditions, they require brackets. That's one thing. Now let's get to another case. One thing that I forgot to mention was in if conditions, you can either do a greater condition or lesser condition or equal to. For equal to, you need to be careful. You need to assign the double equal to operator. Okay, double equal to. Now, what's the difference between equal to and double equal to? Equal to is assignment. That is, you can directly give values like a equal to 10 or a equal to 0 or a equal to 1. Whereas double equal to is conditional operator. It checks. Like it's like, is it equal to 0 or not? Okay. So be careful. You can't type int a equal to 10. Okay, that will throw you an error. You can just write int a equal to 10. And same way, if a equal to 0 also will give you an error. Let me show you. If a equal to 0. See here. Oh, sorry. If a equal to 0. Wait, what? Oh, wait. The if condition won't run. That's all. Just be careful of that, okay? So, 1 second. I heard somebody saying something in chat. Yeah, okay. So, that's something to be careful of. Now, let's go to another case, okay? Now, I need to write a program to check if the sum of two numbers. Okay, no need sum of two numbers. Now, wait, let me get you to another case over here. Let's take a character, char C, okay? And C in C. Now, when it comes to character comparisons, you should be careful of one thing. And let's write a program to check if the character is 5, the number 5. See, as I told you, characters can store everything, right? So if C is equal to 5, it will print out C out character is 5. Okay. Else C out character is not 5. Oh, I'm sorry. Forgot about this. Okay. Now let's check if this code runs or not. Oh, what is this? CH was not declared. Oh, sorry. Really sorry. C. Okay. Now if we type in 5, let's see what comes. Character is not 5. But we typed in 5. Now can somebody tell me what's wrong with the code? There's no error over here. But why is it showing characters not 5 even though I entered 5? Anybody has an answer for that?
Is it because of that we didn't put it in single quotes?
Yes, it is because of that. 5 is an integer. Exactly, that's correct. Now what we are doing here is as you observe, char C means C is of type character. Okay. This is where data types come in. You need to learn data types properly. Okay. C is a character type. And what we're doing here is we are comparing a data type to an integer. Now, this is not wrong here, but what happens here is it's comparing if the value of C is equal to the ASCII value of 5. Okay. But what is the ASCII value of 5? If we go to the previous, we can see that the ASCII value of 5 is, ASCII value 5 will have something called ENQ, inquiry. We don't know that. And the ASCII value of the actual alphabet 5 is 53. Okay. So what happens is it's checking if C is equal to inquiry, and obviously C is not equal to inquiry. C is equal to 5, which is why we won't get an output. Now that's something you have to be careful of. So if you put it in single quotes, wait a second, we have doubt. We put in single quotes, no need, let's leave it to them. If C is equal to 5, now let's check it out. If I type in 5, character is 5, see, it comes correctly. So you have to be careful about what data type you're using so that you can do proper if-else comparisons, okay? Now that was one important part of it. After that, let's go to a classic problem, which most of the people will teach you when you're learning new programming. So this is a program for the greatest of two numbers, okay? A fairly easy program. Let me just run through the program really quickly because today's homework questions are going to be related to how you manipulate data types and how you use if conditions to produce proper results, okay? So this program, greatest of two numbers. Include IO stream using namespace standard int main, int a and b. See, you declare two integer type variables a and b. Now C in a and b, you input the two variables. If a greater than b, a is bigger than b, okay? Else if a less than b, C out b is bigger than a, else C out a is equal, both are equal, okay? So what's happening here? Let's check it out. If a is greater than b, of course a is bigger, a is the biggest number. Else if, now this is where the trick comes. It's not just an else, it's else if, which means if this if condition is executed, it won't execute this else if, or it won't execute the if, okay? On the other hand, if I type if a less than b, it checks this if condition, okay? After that, it checks this if condition also. Then if any of these are true, I mean, if this if condition is true, it will check this. If this is true, it will execute even this one. So both these conditions will get executed. And then it
it's not nested, boy.
See out a, wait, I was able to get that. 1 second. Yeah. So that's one thing you have to be careful about. When it comes to a lot of other programs, you'll have to, be careful about how many, if you are using if else and else. Let's just run this program really quickly. I'm sorry, else let's select two numbers, 5 and 10. 10 is bigger than 5 and 5 and 5. 5 is equal to 5. Okay. So that's a very simple program. Now let's come to another topic called nested ifs. Nested if is used if you need more comparisons than just one comparison. For example, if a equal to 5, then we need to, okay, let's take a program where it checks if a number is even, and if it's an even number, it divides the number by 2. Okay. So if a equal to, okay, wait, not a equal to, if a mod 2 equals 0. Oh, wait, modulus operator. Modulus operator is an operator that gives you the remainder. Okay. So if a mod 2 equal to 0, it means that if you divide a with 2 and you get 0 as a remainder, then it means it's an even number, right? So if a equal to 2, then what should we do? We need to divide it by 2. A equal to, oh wait, that's the same thing as large. It doesn't have any explanation, right? Wait, one second. Let's check. If a is an even number and a is divisible by 4, we have to print the number, okay? If a is an even number and divisible by 4, we have to print it out. If a by 4 equal to 0. Is my voice breaking? Sorry. If a mod 4 equal to 0, see out a. What happens here is it checks if this condition is true, and if it is true, it checks if this is true, and then prints out this. Okay. This is something called nested if statements. Now, instead of doing nested if, we can also do another thing called AND operator. So that is this one. If a mod 2 is 0 and a mod 4 equal to 0. Okay. Now this operator is called the AND operator. So instead of writing two if conditions, we can just write both the conditions in the same statement. Okay. If a and if this condition and this condition is true, then whatever is inside gets executed. Okay. Same thing you can use OR. If this condition or this condition is true. Now these are what are these called? These are AND operators and OR operators. They're you will need them later on when you need to manipulate a lot of we need them when there's a lot of checking, we need to manipulate them. So with that, I think we can end the session. What else is there in today's session? Okay, that's it. Okay, let's end the session. Now ask me if you have any doubts so we can clear it right away. Do you guys have any doubts? No. Guys,
Arjun has asked a doubt. Arjun has asked a doubt. What is an AND operator?
AND operator. AND operator. Let me show it to you. AND operator is okay. AND operator is basic AND in English. It just use. Okay, let me just demonstrate an example. And a equal to 4. Now what happens here is, if a modulus 2 equal to 0 and a is equal to 4, just like reading English, you can just read it like how you read English sentences. If a mod 2 is 0 and a is 4, so it checks if both these conditions are true, and then it executes the statement here. Okay, see out a. Now, if either of this if this condition fails, like for example, if we take the number as 6, okay, I'll give you an example. If the number is 6, it won't print anything because a mod 2 is 0. That's correct. A is an even number, but a is not equal to 4, right? So if either of these conditions fail, it won't give you an output. On the other hand, if we take the input as 4, it gives 4 because both the conditions have been satisfied. Okay. Is it clear now, Arjun? Okay. Now the same thing about AND operator. Let me just OR operator also. I'm sorry. Let me just demonstrate it quickly. If either one of these conditions gets satisfied, it'll just print out. For example, if I enter 10, 10 is an even number, but it's not equal to 4. But since either one of these conditions got satisfied, it's just printing out. If I give an odd number, it doesn't print anything because it is not an even number and it is not equal to 4. Okay. So did that clear all your doubts, or do you have any more doubts? Okay, done from Arjun. Everybody, is it clear? Is this topic clear?
Yeah, any doubts in today's class?
So this is the last topic of today. Okay, this is clear. Fine. Now we'll be going to do today's homework. Okay. I want you all to do this. Like last time we got 9 responses. I want everybody who has attended the session today, like all the 12 of you or all the 14 of you, to do it. This is the question. You have to input the name, marks of 4 subjects and roll number from a user, and you have to print it along with the grades they received. Okay. And if he fails in any one subject, you have to input his parents' number. That 10-digit parents' number. Okay. Is that cool? Did everybody understand the question? Take in a user's marks of 4 subjects and their roll number, and you have to check which grade they have and print out the name and the grade. And if he has failed in even one subject, like just one subject, if he's failed, you have to take his father's or parents' phone number, whosoever phone number it is. Now the next question, the second question is, this is a little tricky one. You have to find the number of ones among this. Find the number of ones. Okay. You'll be given 3 numbers of 5 digits. Okay, 5-digit size. This is a fixed size, and you have to find out the number of ones in this. Okay, and I'm telling you, all the clever people who used for loop yesterday, in the second question, nobody's allowed to use a for loop. Okay, for loop and while loop and all those, nobody's allowed to use loops. You have to use if conditions and all the data structures you learned today. This all